Hi everyone, welcome back to the channel. This is Rosario Borgesi and in this video we will see how to compile, how to deploy a smart contract on Starknet using Starknet Foundry, and we will also see how to interact with it using Starknet.js. So let's get started. Let's start by giving a brief overview on Starknet. Starknet is a layer 2 of Ethereum, which means that it is a blockchain that aims at scaling Ethereum transactions. So aims at allow to the Ethereum blockchain to have an higher throughput and also to reduce the gas fee, so the cost of each transaction. And to do that, it batches the transactions of chain on the Starknet blockchain and bundles them and submits um, on the Ethereum layer 1 a proof of validation, which is also called a zero knowledge proof because of the algorithm that it is used. And in fact, Starknet it is a layer 2 rollups, a zero knowledge rollup. So it is different from the other rollups like the optimistic ones, for example, such as Base or Optimism or Arbitrum, for example. And the main difference between the zero knowledge rollups and the optimistic rollup is that while um, the EVM of the optimistic rollup it is compatible with the EVM of the Ethereum mainnet. So this means that a smart contract that can be written with Solidity for the Ethereum layer 1 can also be written at in the same way. The same smart contract can be deployed in Solidity for an optimistic rollup. Instead, since as we said earlier in Starknet, we need to provide a proof of the validity of our transaction, we cannot use the EVM of the Ethereum layer 1, but Starknet has deployed its own EVM with its own programming language, which is Cairo, that is not compatible with Solidity. So we cannot deploy on Starknet a smart contract which has been deployed, which has been created, written in Solidity. We must write our own smart contract in Cairo. So this is an Ethereum article that I have written for this video to guide us throughout this video. And to create a smart contract in Starknet, we need to use Starknet Foundry. Starknet Foundry is a little bit different. It's totally different in reality from other tools that we have. We have more experience with, like, for example, Ardat with the Ethereum layer 1 that allow us to compile and deploy the smart contract by using JavaScript files. But in this case, Starknet Foundry, it is works from the command line. So we need to start a new project. We need first of all to install all the dependencies. You can find the guide here um, in this page. So we need to install all these programs on Linux or in macOS. The the documentation is very well written and it is pretty easy to install all this stuff, but you need to install all these programs. Once you have done this, you can start a new Starknet Foundry project with this command here. So then another important thing is that we cannot use, for example, MetaMask with Starknet, but there are others wallet that are compatible with Starknet. For example, Bravos. I have an example here. So this is, for example, my wallet number 2 in Bravos. So you need to create, if you don't have it, your wallet with Bravos, and then we need to import this wallet, this address um, into our project, into Starknet Foundry, and we do it with this command. So we need to define this is the RPC URL, the name it is account Bravos. Here you put the address of your account, and then here you put the private key and the type it is Bravos. Of course, I have linked here all the documentation if you want to explore it further. So this account are saved in a file which is this one at this path here. And then I have imported the account both for the mainnet, so Starknet mainnet and Starknet Sepolia. If you open this file, it should look something like this. Okay. You can also check the lists of your account by running sncast account list. So once we have imported our account, we can also, and we have started uh, our project, there is a file in our repository. Of course, I have uploaded the repository on GitHub, so you can find this some similar files uploaded on GitHub. You need, if you want to configure this file snfoundry.toml with you can provide in this file the account configuration, for example, like I have done here. So you put the RPC URL, the Starknet file, which is always the same, and the type, the account name, sorry. So this is an example of account that I've created, in this case for Starknet Sepolia, and this is another account that I've created for the Starknet mainnet. So once we have done this, we should also write the dependency, because in this project we will use the OpenZeppelin library to create our ERC721. You should also put this dependency in the file scarp.toml. So our file scarp.toml in the end should have these two dependencies. Then, of course, if you are on the testnet, so on Sepolia, you can use the Starknet faucet to get, sorry, it is this one, the Starknet faucet to get some test tokens. So you provide here, for example, your address, you select the token STRK or IT, and you request your tokens. And then to build our smart contract, we can use, for example, we can start from the OpenZeppelin wizard that you can find here. So you start here. As you can see, you can have Solidity or Cairo. You select Cairo, ERC721. You make your smart contract mintable, for example, enumerable, and it auto creates your smart contract. Here it comes already with the ownable. It inherits from the ownable smart contract, but In this example, I have removed it to make the contract easier to use. So I have also added a counter, and I've also added a map, which is this one. Here you can find the counter, a map token URIs to allow for storing the token URIs associated with each token ID. So here I've also uh, exposed these three methods: get token URI, set token URI, and the mint item that have been developed here. Very simple method, nothing too fancy, just to have um, a smart contract which we are more used to use with Solidity, with all that we have done in Solidity. So this project, this file should be put inside the lib.cairo file that is located in the SRC folder. And to let you see how everything should be like, you would end up with a repository like this. So you have your file scarp.toml here. So as you can see, there are the dependencies that we have talked about. This file snfoundry.toml. Here I have you have to put your own URL. Okay, very simple. Here you have the SRC file with the file lib.cairo, which is the smart contract that we have seen earlier. So it is everything very easy, very straightforward. So coming back to our article, now we have created our own smart contract. We have written it. Now we need to do two steps in order to deploy our smart contract. We first need to declare the smart contract, and then we need to deploy it. When we declare the smart contract, um, we get the class hash. So let's try this the declaring of this smart contract. So here we are in this repository. We need to run our smart contract is called labels. We need to run this. So declare -v sncast declare -v v3 -c labels. If we use v3, here we will pay the fees in strk. If we want to instead to pay the fees in it, we should use v1. Sorry, v2. Okay, so let's run this. This will compile our smart contract. Okay, the smart contract in this case it has already been compiled because I have already compiled it. So once it has finished, it says to me it has finished compiling. It says execution error class with hash is already declared because I have already declared this smart contract. So the next thing to do is to deploy our smart contract. So we need to use this class hash here that it has been created for us to deploy our smart contract. We're gonna use this code here. So sncast deploy -v v3. In this case, v3 means strk to pay the fee in strk. If we want to pay in it, we need to put v1 class minus hash. This is the class hash that we have obtained before. So once we run this, So our smart contract has been deployed at this address. Okay, I copy this address here. And this is the transaction hash. We can check the transaction hash of course on StarkScan Sevolia because we are deploying in Sevolia. This is my address, as you can see here from Bravos. And here it says that we have called the deploy contract function, so we are deploying a smart contract. And it's very simple here, nothing particular. So the fee, as you can see, is pretty low. Um, now, now we need once we have deployed this smart contract, we want to test it. To test this smart contract, to interact with it, we need Starknet.js. So we need to create a new um, repository, so a Node.js application where I have installed simply Starknet, the Starknet.js here and TypeScript and .env. There is nothing special here. Here we have this file index.ts. So what we can do before we start, one thing we have to create a .m file in the root, as you can see here, and we need to provide the Starknet address. So this is the address of our account, our private key, and the RPC URL. And so we are ready to start. So this is the address of the smart contract that we have deployed on Sevolia on the testnet. So here I already have some very simple function. This is a function that calls the method total supply of our smart contract. This is a function that calls the get token URI, so to get the token URI for a specific ID. This is another function that calls the function balance of our smart contract. And here we have a function that means a new NFT. So it calls the function mint item that we have written in our smart contract. So these are all total supply, get token URI, balance of, and here mint item are all functions that are present in our smart contract. We are calling our the smart contract that we have deployed on Starknet Sevolia. Here we have also get contract name to here we call the name function of our smart contract. So we could start, for example, by calling the name of our smart contract. Let's comment out of this line. We just need to do npm run. Okay, as you can see here, the contract name, it is labels, so it is fine. So let's start now to deploy a new smart contract, sorry, a new NFT. So here we are providing this function. So here we are providing the recipient, so the address that we receive the NFT and the URI, which is a string. You could pass here, for example, an IPFS URL. I am passing a simple string. And so here we are saying version 3 to pay this fee since STRK. If we don't want to pay our fees in STRK and we want to pay in it, we just remove this object and we are fine. And so we are logging here the transaction hash and the receipt of our transaction. So we simply run again this file. So this is pnpm So this is the transaction hash of our NFT. Let's wait for the receipt. Okay. This is the reception. Okay, execution status succeeded, accepted on L2. We can check our transaction like we did earlier on Sepolia scan. So we put here the transaction hash. Okay. So this is as we can see here. Okay, this is an NFT transferred. Here it says that we have transferred an NFT from, of course, 000 because it is a smart contract to my address, which is this one. This is the fee that we have paid in STRK, as you see here. And I was looking for the, here there are also the input data. Okay, it does not say anything. Let's say here. Okay, transfer. Okay, I thought it would have said something more. No, okay, fine. So here it just says invoke function. Okay, because we are minting, we are calling the function mint NFT. And okay, fine. So in order to prove that we have correctly minted this NFT, we can go back to our code. We comment out this and we can execute these three functions. So this function checks the balance of this is my address, so it should be 1. This function console logs the token URI of the first NFT, the one that we have already minted, and this one checks the total supply of our NFT, which should be, of course, 1. So if we run pm run dev, okay, we see that the account, this is my account, has 1 token. The URI of the token 1, it is NFT1 because here we have passed NFT1 as a token URI, and then the total supply, it is 1. So we have reached the end of the video. I hope that it has been useful. If you have any questions, feel free to drop a comment below. Thank you for watching and see you in the next video.